I'm Emmanuel Thomas. I'm studying at fourth year student at BTech BTech as Muthoot Institute of Technology and Science. I'll be handling the second session of the Gen AI course, which is of 5 days. So I hope all of you are interactive throughout the session. It will be a hands-on session. So to begin with, I'll share a collab link of the code which I have in the group. Yeah. So is everyone able to access the collab link? So what I want everyone to do is open the collab link, and when you go to the plus on my screen, so is the screen visible? Uh, so when you go to the collab screen, you have to save a copy in Drive or make a copy of this file. As I have set this collab link to a view only collab file, you have to make a copy of the collab file, and you can then edit on this collab file you have created and run the code with me. Is that clear? Yeah, so I'll give you a minute to create a copy and save that file. Yeah, so did everyone create the collab file? So it's done. So I'll give a brief intro of the session we'll be handling today. Yesterday, you might have got a brief introduction about what an agentic AI is and how LangChains works, what a pipeline is. Today, I'll be giving a hands-on session on how to set up a Python environment, the LangChain framework, and I'll explain a tool with a sample code, and I'll build a AI research agent, which is based on the React concept. And then, so Advait asked about regarding the hackathon. So it will be later addressed in the group. I do not have any knowledge about the hackathon part. You could ask it with the organizers. Arnav,
Yeah, of course. Like I heard there is a small 1,000 rupees for the join after you have been settled in hacker.
Okay. So we'll be building an AI research agent that will be based on a React concept and math or logic agent, which will be based on a plan, act, reflect concept. And we'll be discussing about these concepts. So first and foremost, when we set up an environment, we have to install the dependencies in Python. So I have included an exclamation mark. This exclamation mark is used so as to um, run it as a shell command. Currently, the code which is run in a code block is considered as a Python code. But when we use the exclamation mark, the Colab file considers it as a shell command and runs it in a shell way. So this can be used. We install dependencies in the shell. If we are using VS Code, we'll directly give it as a shell command pip install. So here we use the exclamation mark to run it as a shell command and pip install to install the dependencies. And we have used a minus q. Does anyone know why we have used a minus q? The rest of the parts are the frameworks or packages we have downloaded. Anybody with any answers of why we have used a minus q in between? Uh, I am getting no responses. Yeah, it's for the quiet. So if we run these code like simply without minus q, it will have a lot of downloading lines. It will take up half the page of this program so as to download it step by step. But by using the minus q, this code will just be run in a 10 to 20 lines. That is the shortened version. Otherwise, it will take many lines. Since I had already run it, the dependencies are installed, so it doesn't show. Otherwise, you'll get a 10 to 20 line of downloading data. So to work with this Google environment, we have already installed the dependencies. Now we need a Gemini API key. So I have chose the Gemini API key because it's a free API key. We have OpenAI API keys, which lets us access the models that are already created by Gemini or OpenAI, ChatGPT, etc. So Gemini Group provides APIs where several platforms provide us API keys. So we could get API keys for image generation, get API keys for LLMs, for text analysis. Did anyone ask anything? Okay, so I was saying we could get. Hello, your voice is your voice is breaking. Could you type it? Rida, your voice is breaking. I could not hear the question. Could you put it in the chat box? So we'll get back to the question once she types it in the text box, or if anyone has any doubts, please ask. I am audible, right?
Yes.
Yes, okay. So, as I was saying, we have to, so for processing, for creating a tool. So, we are currently going to create a tool. For example, in the current example, we are creating a BMI tool to calculate the BMI. So, to do this, we use an API key. We use the API key because it has models. This API key helps us access models which are complex models. So we could run it without. So if we try to create a model on our own, take a lot of processing, and the system will not be able to handle this. So it takes a time of processing, and it needs a specific GPU, or it needs a data energy requirement of the GPU. So this we won't be able to develop a model and run it on our own. So we use API keys which provide access to models which were developed by Gemini, OpenAI, or Group. So I want everybody to create a API key. So what you want to do is go to Google or a search engine, search Google AI Studio. When you search Google AI Studio, you'll reach a page like this. And on the bottom left corner of the page, you have an option, Get API key. So what I want you to do is click on the Get API key, and you could create on the top right hand side, you have a Create API key button. Click on this button and name your key. For example, I am naming my key test. And since you may, if you have not worked with projects of using API keys, you may not have any projects. So create a project if you do not have any projects, or if you have any projects, you can use it. Click on the create project button, and I am creating a project Agentic AI. Click on the create project. So I have created a project Agentic AI. The name of the key is test, and now I create the key. Once you have created the key, it will be listed down with the API key section. So I have the Agentic AI key here. Click on this button or any of the hyperlinks so as to get a detail. Here you need to copy the API key. Just copy this, and we'll set up a environment file for this API key. So I want everybody to create an API key for now. Could ask any doubts if you have it regarding this creation. I'll give a minute for everyone to create an API key. Rajwal, Achila, Srilathan.
Can you please repeat the last step?
What should I repeat?
The last step
Regard.
after creating the key.
Okay. So once you have created the key, the keys will be listed down as in the given format. Create, click on any of these hyperlinks, Gen AI button or this key button, and you'll have a description box like this. From this box, select the API key. Here you have the copy button and copy this API key. Clear?
Yes, thank you.
Hope everybody has created an API key. Yeah. So uh, I just forgot to explain the dependencies and the detail of each package we have downloaded. So I'll just give a brief explanation. Here, the Google Gen AI package. Each one of these dependencies I have installed. Google Google is a single package. Gen AI is a module in that package. And LangChain is single package. This LangChain is single package. Since I want the Google module and Gen AI module in the Google, I have given LangChain slash Google slash Gen AI. And to work further on LangChain, I have given the LangChain and Python dot plus dot env. Currently, we do not need this, but if you are creating a project on your device, you need to set up a virtual environment. I'm not going through that process in this collab file because since it's a collab file, it also already runs on a cloud environment. You do not need to set up a virtual environment. But if you are building it on a PC, you need to set up a virtual environment. And for that, you create a python.env file. The .env file consists of the API keys, information like information for passwords or other database links. All are stored in a .env file, which will be which. So if you push your project to Git, you will not push the .env file. It will be ignored since it consists all of the confidential data. So here the Google Gen AI package is used to run the Google model, the Gemini model. When we call it, we use the Google Gen AI package. I'll show it to you in the code. And we use the LangChain Google Gen AI package to integrate the links between LangChain and Gemini. LangChain is, LangChain is a pipeline-like model, and which is integrated with the Gemini model so as to get better accurate results. And the LangChain package consists of Google and Gemini packages, modules. It consists of all the operations we can do on LangChain and what if we will use to implement the React and plan at reflect agents. So that's it. Now we'll get to the code bit. Um from getPass, import getPass. So we use the getPass module. This module is used to hide our API key. Our API key is secret information. You do not want to show it. When you run the code, you'll see a text box to enter the Gemini API key. Then you enter it, it will be converted to dots like in a password. So we use getPass for this and OS to show the OS dependencies like software environments and runtime environment side details. And from Google, we import Gen AI. So this is a code bit in which we will check if a API key already exists in this code. Like I already have given the API key once, so this runs without receiving an API key. So if an API key is not in the environment, os.environment will read a API key using the getPass method, the getPass function, which will hide your API key when you enter it. Client equal to genai.client. So this will set up a client module with the Gemini API key we have just received. Once you run, since I have already run it, I am not getting a prompt to enter the Gemini key. When you run it, you'll get a prompt to enter the Gemini API key. You have to enter this copied API key in the prompt, and you will get a successful run, and your environment will be accepting the API key. Yeah. So everybody could do that. Any doubts or partial? What was the problem you have faced? No doubt.
Luck.
So the next topic we are heading into is tools. So a tool is a specific module which does a specific task. For example, janitor, we need to enter the copy keys. Like in the Google AI Studio, you have a given API key. Just copy it and paste it on the prompt which comes once you run the module. So I'll move on to the next topic. Our next topic is to build a custom tool. Tools are a function or a module which does a specific task. In the given example, I have taken a BMI tool. This tool decides which tool to use, which arguments to pass for the Python function. Ask Gemini to explain the result very nicely, which I'll show you in the further steps. So while calculating BMI, we have two parameters, weight and height. Everybody is familiar with BMI, right? Body mass index. Yeah. So we have two variables, weight and height. So this is a function calculate BMI. This is a normal function. We'll just calculate the BMI where HM is the height divided by 100 and it returns round of weight divided by this HM star 2, which is round to the value 2. That means only the first two decimal numbers will be taken since a long irrational number might occur while we're calculating this function. So this code bit just defines the calculate BMI function, which returns the BMI value. So this is our main code bit, which is divided into two sections. In the first section, we'll define a tool prompt. You are for the tool, we'll describe a prompt which will be given in a multi-line text. You are a tool calling planner. User will ask something related to BMI. Your job is only to decide which tool to call and with what arguments you must respond. So we are telling the model how it should work. You must respond only in JSON. In JSON format, uh, I'll show you in the output when how is the raw text differing from JSON format. We need the output in a JSON format so as to pass it through databases, or when we need to transfer the data through the net, it is converted to JSON format. And once it reaches a so client side, we interpret JSON detail and convert it back into raw text. And when we need to pass the data into a model, we use the JSON format so we can understand easily. So that's why we use JSON. So here import JSON is used to convert the text into JSON format, and RE is used to remove raw like white spaces. So if we enter text, you are a tool calling planner. We have white spaces here, white spaces here, simple spaces in between. We'll exclude that using the RE function or the strip function of the RE package. So here we describe a tool prompt which gives the detail of how we should, uh, which tool it should respond with, which parameters, like tool is calculate BMI, its function, and the parameter arguments, which are weight and height. So user question, we define a user question. All of you can edit this if you need. You can edit the user question, or you can edit the tool prompt so as it will work differently. The Python code. The weight is six. So in my example, I have given it as weight is 68 kilogram, height is 172 centimeter. What is BMI and is it healthy? So the BMI part is calculated using the function, and is it healthy? So it gives the BMI calculate values into a model, and this model converts the data and checks whether it is healthy and gives a output regarding to the prompt we have entered. So we'll head on to the response part. This is the prompting part, the question part. Now we'll head on to the response part. So our client is the GenAI model, the API key we have used, and we initialize it into a client model. So client.models.generate content is used to generate content using the model of the client API key we have used. In the response given as a client model to generate using the model Gemini 2.5 Flash, which is a model for the specific API key. And the contents of this 2.5 Flash, we pass the content as tool prompt and user question. So this whole text, you are a tool calling planner, my weight is 68, is passed as system instruction and user question into the Gemini 2.5 Flash model. This Flash model produces the output into response variable. Now we use a variable raw text, which takes the response raw text, and this raw, the response consists of other characters or white spaces, which will be extracted via response.text, and we print the raw model output as raw text. So this is the format of a raw text. Here tool is calculate BMI. Since we have defined the tool as calculate BMI, we get the tool as calculate BMI. Argument weight is 68, height is 172. The argument weight and height number is extracted from the question, and this is the raw model. Once this raw model is created, we convert into a JSON.text. So raw text.strip is used to remove white spaces in this raw text. So if there are any unwanted spaces in this raw text, this process raw text is perfectly fine. So it does not need any formatting. But in certain cases, we need to remove spaces or convert it back into a JSON format. This given generated raw text is in the correct format of a JSON file. So once we do it as a convert it into a JSON file, we do not see any specific changes. But if it consists of any white spaces or if the data is not of a for particular format, the JSON format is like the whole data must be in curly brackets and each variable tool it consists of key value pairs. Here tool is the key, calculate BMI is the value. Here args is the key and this for curly bracket another JSON format file or a JSON text is a value in the args key. So this is the JSON format and each key value pair must be separated by a comma. And the text, the strings in a JSON file must be defined using double quotes. These are some basics of web programming and a JSON format I have explained here. So what the rest of the code does is that we search if any triple brackets like commented code is there or any unwanted code bits like if in the raw text I had uh, add an explanation or extra. Do not add an explanation or extra text as entered in the raw text. If it accidentally entered in my raw text, this code bit will edit the this code bit will edit that raw text back into JSON format and it will convert it back into a key value pairs. That is what the JSON this code bit does, and it strips any white space off. And finally, we'll use the JSON.loads to print the JSON.text. We have just pre-processed the raw modeled output and so we print the tool call. Tool call is a variable I have declared so as to save the clean JSON file. In the next process of creating a tool-based mechanism, we'll have to call this tool call, which gives us the output. So does anybody have any doubts regarding this? Now we'll jump into the final stage where we process it in an explanation form. So does anybody have any doubts or should I explain anything? Okay. Yeah. So now we'll get into the execution part. Here we have a process text format of the weight and what function, what tool we have used. Here we only have a single tool that is to calculate BMI. But if we had to calculate something like the weather predictions, we'll have different tools for different areas or different regions. We'll have to separate the tool according to the area of the given user question. We give a args args variable, which calls the tool call argument of args. So what args is a variable which stores the calculate BMI value. Your tool call of args is sorry. So args is the variable which tool tool call consists of tool and args keys, as I have mentioned earlier. So while we call tool call of args, like you have dealt with arrays, right? So when you create arrays or dictionary, for example, in dictionary we have an args. We'll use this as a key and this as the value. So when we call the tool call of args, it saves the weight and height into this args variable, and BMI value is equal to calculate BMI of. So what this does is it converts the BMI value. We have the calculate BMI function here. The 62 and 172, 68 and 172 variable is passed into the function, and the BMI corresponding BMI value um, is stored in the BMI value variable, and we print the calculated BMI value is 22.99. This is what the tool variable does. The tool identifies what tool is to be selected from the given functions, and it predicts the BMI or the output. So now we have to do what we have to deal with is whether he is healthy. The model part where a level of thinking is required. Now we'll ask Gemini to explain about whether it is healthy. So I have defined an explanation prompt. Later, in the first section, we had a tool prompt, which is to select which tool from the given model. And in this part, we have an explanation for prompt on how to explain the details we have currently received from the execution phase. You are a health assistant. User question, which is user question, like my weight is 68, my height is 172. That was the user question. Tool result is the BMI value, that is 22.99. Explain what this BMI value. This part we could change. Everybody could give it according to what they need, what prompt. Like if you use ChatGPT, everybody might not give similar prompt. They'll give different according to the needs. So you could change this part in the text here itself, and what this BMI mean. You could give how whether it's in healthy range. You could give how to reduce this BMI and keep it short and clear. If you do not want it short and clear, you give a longer answer. All of this prompting part would be edited, and up to here the multi-line explanation prompt consists of this much part is the explanation prompt. And now I'll again call the Gemini 2.5 Flash, which I have done earlier while the tool prompting mechanism. Models.generate content to generate the content is in the Gemini 2.5 Flash model. Here the content is explanation prompt, which is this prompt I have given. And this final response will be stored on the final result of the explanation prompt and the model using the model Gemini 2.5 Flash, and we'll print the final response.txt. So here we can see this means your weight is in the healthy range. It will give. So what this BMI means: eat a balanced diet, focus on whole foods, whether it's in healthy range, stay active regularly, aim for at least 150 minutes. 2 to 3 simple lifestyle tips. Prioritize sleep and stress management. So it will give according to the prompt. You could edit the prompt. Also, you could edit the tool prompt, which will give different answers according to your prompting skills. Yeah, so this is the tool part, and we have covered half of the topic. So anybody have any doubts? Then ask now. Yeah. So the next topic we are going to cover is we are going to deal with it with two examples. The so if we are given a question, we have two, which is the reason plus act pattern and the plan act reflect pattern. And I'll first explain the React pattern. The React pattern is a LangChain research agent. It uses LangChain pipelining so as to it will think we'll give a query. It will think on the query, act, and see uh, after a specific act is done, it will do the next thinking stage and act again, and it will think and give the final answer. It does not have a feedback mechanism. It will only flow in a straight path. It doesn't work from feedbacks. So in a LangChain version, we'll have a thought plus a search plan. The prompt will be given in a thought, search plan, summary, insights format. We'll just move in a forward pipe. So what a pipeline is, will only move in a straight direction, but it will not work on feedbacks. So this is the LangChain pipeline used in React pattern. Uh, so this is the React pattern is used in web search, the research agents, which I'll explain, API agents, the RAG systems. These are some examples of which React pattern is used. Now I'll explain that it plans a specific way how to do this query. For example, I have a mathematics question. What is 2 plus 2? I'll plan it is we should add two numbers. Then it'll act 2 plus 2 is equal to 4. It'll give the action. Then we'll reflect on the output whether 4 is the correct output. We'll check whether 4 is is the correct output. If 4 is the correct output and there is no change, we'll give the final answer. In our prompt form, in our prompt, we'll have a plan block, act block, and a reflect block. Uh, Plan breaks the problem into steps. What our problem statements, it is broken down into simpler steps. And in the act phase, we'll execute these steps. And in the reflect phase, we'll check whether any mistakes have occurred and if the given answer is correct. If some mistakes have been occurred, then we'll edit the mistakes and we'll again plan the edit phase and act again. So this is how the plan act reflect works. It some examples are mathematics questions, coding questions, finance, and legal reasoning. So these are some examples. Now I'll get into the examples of our discussed patterns. This is a research agent example. So everybody, I hope everybody have done this BMI calculator one. Is anybody pending to do this BMI calculator one? Yeah. So this is a research agent example. What the research agent does is it does a web search. So if I have a topic of agentic AI itself, I'll do various web searches on agentic AI. Then summary will be generated, and this summary is processed, generate 3 to 5 actionable insights for a chosen audience. So the summary will be generated, but according to the chosen audience. That is where agentic AI comes in. According to the chosen audiences, the insights will vary. According to the prompt we give, while we code, the output that is given. So I am a proficient agentic AI. Like I'm taking class for you, so I'll have a minimum level of proficiency in this agentic AI sector. So while I search for agentic AI and its details, I need a higher level of output. From the given summary, it will give me a higher level of insights. If any of you, like beginners, are given agentic AI, you do a deep research of agentic AI, then this model predicts insights for beginner level, and it will be more easy to understand. That is what this model does. Now we'll get into the code part. From LangChain core dot prompts, like I said earlier, LangChain core and LangChain Google Gen A. LangChain core is the core LangChain package which is used to store the chat prompt template. The chat prompt template is a function or a module which it's a chat prompt template. It's a function which accepts the string which is of the format of the chat we have to execute. I'll explain it in the code. And LangChain Google Gen AI, Chat Google Generative AI is a function which merges the Gemini 2.5 Flash model with the LangChain framework we have set up. So, did you get the brief explanation on LangChain yesterday? Anybody respond? Am I audible? Yeah, you got a. So, I hope you'll be able to keep up. So, this uses a LangChain model. It's a pipeline model, and yeah, the Google Generative AI function is used to integrate the model with the LangChain pipeline. So first, we have declared a variable LCLLM. Then we use the chat Google Generative AI, which takes model as Gemini 2.5 Flash, the model we have been using since beginning, and temperature is 0.2. So what temperature is? We'll deal with temperature in the next math plan actor tech also. So what temperature does is it varies from 0 to 1, 0, 0.1, 0.2, 0.3. It refers whether the model is deterministic or it is creative. So consider temperature is equal to 0. In this case, the model is purely deterministic. It will only work with the given context. Uh, in this prompt, you are a research agent. It will only follow these rules. And it will get the web search and it will only follow these rules. If we, as we move higher, 0.2, 0.3, 0.5 is a neutral state, and 0.5 and above, the model's creativity increases. So it will not stick directly to uh, this given set of rules. It will fluctuate a bit. It will use a creative mentality to uh, give creative answers rather than what you say deterministic. So I'll give a simple example. So if I face a problem, I have to get a topic from a final year project or a mini project. So if I use a deterministic model, like the temperature is equal to 0 or less than 0.3, it will not be able to creatively give me new ideas. It will just be deterministic and work with the ideas it have. But if the temperature is 1 or zero point 0.7 or higher, I'll get more creative ideas. That is what uh, That is what the temperature does. I'm audible, right? If, I have seen some of you leave. Yeah. Okay. So what that is what temperature does. Um, and when I need to learn a topic, tomorrow I have an exam and I need the answers from the PDF I uploaded itself. So that is when I use temperature is equal to 0. That is highly deterministic. It'll only give answers from what I have, what the model works with. That is why what temperature does. Hope everybody is okay. Everybody got it. Now I'll define a function LC research listener. This is the question functioner. And in this question functioner, we'll give two, I will give a single variable, that is the str. The str here is defined as a prompt using the chat prompt template, which is a core prompt function of the LangChain core. It is a function from the LangChain core module, or LangChain core package, and this template is of the format as I have given. This is a research agent using the reason act pattern. So it's taught in the structure things step by step what you need to know. Search plan, write 2 to 3 search queries you would use on the web or of the given topic. Summary, to give the summary of the queries we have retrieved. Insight, give 3 to 5 short insight or action items for the user. It will also be based on the user question. User question means uh, so what are some common hackathon use cases? That's the user question. And will be worked through this format. And this is a template from the chat prompt template. Also, you could edit these prompting bits. Just follow the thought search plan summary insights format. Just edit what you have written inside these blocks so as to get the different ideas or different outputs. And this is the define LC research reasoner function, which defines the module. And chain is equal to prompt LLCM, LCLLF. This is used to create a pipeline, so it moves in a forward way. Things acts again, things act, it moves in a forward way. And a response is equal to chain.invoke question. So what this does is it takes the response of the chain pipeline into the response variable. So um, it will pass this prompting set format template into the Gemini 2.5 Flash model, and it will generate the response using the invoke function that will be stored into the response bit. And finally, in this LLM, LC research reasoner, it finally returns the response content. So our current user question is, what are the common hackathon use cases? We have given a slight bit of 0.2 bit of uh, temperature, so it will be highly deterministic. It won't be creative. So once we run this code bit, first this question is passed into the structure, and it takes some time for the research mechanism. It will follow all these steps. This question, what are some common hackathon cases? It will think about it, search different queries, different variables of this queries, variations of this query, summarize it, and yeah, it thought. The user is asking for common hackathon. Define agentic AI for hackathon. Brainstorm hackathon themes. Connect agentic AI to themes. Common characteristics of agentic AI. If you are of the thought phase, this is the search plan phase, which it uses for web search. These are three queries it uses for web search. This is a summary of the whole web search it has done. And once the web search is done, it'll give the insights. It's our final output. Focus on tool use, define a clear goal, iterate on memory. That's it. So, if anybody has any doubt regarding the result agent page or the reason act pattern, that is clear, we could move to the
Hello.
yes, the
Web search build ആയിട്ട് വരുന്ന പ്ലാൻ ചെയ്യല്
yeah, അത് ഇൻബിൽട്ട് ആയിട്ട് തന്നെ വെബ് സെർച്ച് സോ ഇവിടെ ഈ യൂസർ ക്വസ്റ്റ്യൻ വാട്ട് ആർ സം കോമൺ ഹാക്ടോൺസ് എന്നുള്ളത് നമ്മൾ എടുക്കും. എന്നിട്ട് ഇതിനകത്ത് ഈ ക്വറീസ് ഏജന്റിക് എ ഹാക്ടോൺ ആൻഡ് പ്രൊജക്ട് ഐഡിയാസ് ഓട്ടോണോമസ് അത് 3 ക്വറി ആയല്ലോ.
ഓക്കെ
ഈ 3 ക്വറീസിനെ യൂസ് ചെയ്ത് വെബ് സെർച്ച് ചെയ്യും. അത് ഇൻബിൽട്ട് ആയിട്ട് 2.5 ക്ലാസ് മോഡലിൽ ചെയ്യാൻ പറ്റും. അത് നമ്മൾ ചെയ്യുന്നല്ല, മോഡലിന്റെ കേപ്പബിലിറ്റി കാരണം അത് തന്നെ ചെയ്തോളും. അതിന് കിട്ടുന്ന സമ്മറിയാണ് ഇത്. Any other doubts?
പിന്നെ മറ്റേ ചെയിൻ ഈക്വൽ ടു പ്രോംപ്റ്റ് ആ പൈപ്പ് ഓപ്പറേറ്റർ എന്തോ ഉദ്ദേശിക്കുന്നു കമ്പൈൻ ചെയ്യണം.
സോ നമ്മൾ ഈ LLM എന്ന് പറഞ്ഞ സാധനല്ലേ, ഇത് ഗൂഗിൾ ജനറേറ്റീവ് AI ആ മോഡലും ടെമ്പറേച്ചറും കൂടെ ഡിഫൈൻ ചെയ്തിട്ടുണ്ട്. ഈ പ്രോംപ്റ്റ് എന്ന് പറയുന്നത് ഇതാണ്, ഈ കോഡ് ബിറ്റ്. അന്നേരം ചെയിൻ എന്ന് പറയുന്നത് നമ്മൾ പ്രോംപ്റ്റ് LLM. പ്രോംപ്റ്റ് ആദ്യം ഈ പ്രോംപ്റ്റ് നമ്മുടെ ക്വറി തിങ്ക് എന്ന് പറഞ്ഞ ഒരു ഇത് പറഞ്ഞില്ലേ, അപ്പം ഈ ക്വറീനെ ആദ്യം പാസ് ചെയ്യും, എന്നിട്ട് ഈ LLM മോഡലിലേക്ക് പാസ് ചെയ്യും. ഇങ്ങനെ ഒരു സീക്വൻസ് ആയിട്ട് അത് പോയിക്കൊണ്ടിരിക്കും. പ്രോംപ്റ്റ് കഴിഞ്ഞിട്ട് ഇത് പൈപ്പ് ലൈൻ ഓപ്പറേറ്റർ LLM, ഈ ജെമിനി 2.5 ഫ്ലാഷ് അതാണ് LLM വിത്ത് ടെമ്പറേച്ചർ പോയിന്റ്. പ്രോംപ്റ്റ് ജെമിനി മോഡലിലേക്ക് പോകും, പിന്നെ വീണ്ടും തിങ്ക് ചെയ്യും, പിന്നെ എന്തെങ്കിലും ആക്ഷൻസ് ചെയ്യാനുള്ളത് ചെയ്യും, വീണ്ടും തിങ്ക് ചെയ്യും, വീണ്ടും ആക്ഷൻസ് ചെയ്യാനുള്ളത് ചെയ്യും, തിങ്ക് ചെയ്യും. അങ്ങനെയുള്ളൊരു പൈപ്പ് ലൈനിന്റെ ഒരു മോഡൽ നമ്മൾ ഡിഫൈൻ ചെയ്ത് വെച്ചേക്കുന്നതാണ് ഈ ചെയിൻ ഈക്വൽ പ്രോംപ്റ്റ് LLM എന്ന് പറയുന്നത്. വേറെ ആർക്കെങ്കിലും എന്തെങ്കിലും ഡൗട്ട് ചോദിച്ചോ? everybody ഓക്കെ ആണെന്ന് തോന്നുന്നു. ഞാൻ നെക്സ്റ്റ് നമ്മുടെ ലാസ്റ്റ് ടോപ്പിക് ആണ് ഇന്നത്തേക്ക്, which is a plan act reflect pattern. So I'll move into the last topic. This is a plan act reflect pattern which is based on a feedback mechanism. It takes a, for നമ്മൾ current example mathematics question explain സോൾവ് ചെയ്യാനാണ് ഈ പ്ലാൻ ആക്ട് എഫക്ട് പാറ്റേൺ ഉപയോഗിക്കുന്നത്. ഇറ്റ് ടേക്സ് എ മാത്ത് ഓർ ലോജിക് വേർഡ് പ്രോബ്ലം. ഒരു വേർഡ് പ്രോബ്ലം അല്ലേ, ലൈക്ക് ഇഫ് ഐ ഹാഡ് 2 cows and 1 cow is dead, how many will I have left? That is a word problem, a sample word problem. We'll take a word problem, decompose it into steps, solve it step by step, and reflect and verify the answer. So yeah, this is the math or logic agent code bit. I have personally defined a math or logic agent um, function which has problem as the keyword. So the problem we have defined here is the prompt, the string, is in the string variable. This prompt is you are a meticulous math and logic tutor. Follow the structure exactly, which is plan, act, reflect, and the problem statement, which is given. So you could change this plan according to your needs. And as I said earlier, not repeating it, uh, will follow the structure of plan, act, reflect, and the problem is given in the function itself, problem string, and the here is the prompt string. And once the prompt is set up, it moves to the response part. In the response part, it uses client.models.gen. Oh, okay. Yeah, it's in the types not defined error is occurring in the math logic agent, right? Am I right? Yeah. I'll give a code bit. I'll edit it right now. Yeah, so you just have to write this code from google.gen AI import types. I'll paste it in the group. Just add that code bit into the top of the function math logic operator. It's working, right? Let me know. Yeah. Yeah. So I'll explain what types is it while I reach the response part. Yeah, and here we have the problem, which we could receive from the user. In the case, I have given a prompt which I have typed it. You could also uh, use int input or input input a string from the user so as to receive it as uh, entry time variable, and you can pass it in the function, and it will use the plan act to reflect the given prompt according to what it's given, and it will also work on this problem bit. Now we'll get into the response part. So in the response part, you'll use client.models.generate contents. That is to use the model Gemini 2.5 Flash. The content here is prompt, which is this you are a meticulous math and logic. It is a plan act reflect place. And config is equal to types dot generate config where temperature equal to 0. So we have used this config type so as to give a temperature value in this model. Use the generate content config. In the previous example, we used the Google Chat Generative AI function to generate to give the defined temperature. But in this example, we use the plan act. We use the types variable to define the temperature. And what we'll be doing is we'll pass the problem statement and the prompt into the Plunge into the. I'll get back. So sorry for the inconvenience. So what this does is it into the client model and passes it through the Gemini 2.5 flash with this prompt, plan active flex prompt, and temperature is equal to 0, which is highly deterministic. It follows the given plan act reflect phase and plan. In the plan phase, we determine the individual filling rate, calculate the combined filling rate, use the combined rate time total time. In the act phase, we'll determine the rate of pipe A, 1 by 4 by tank per hour. Yeah, this is a mathematic phase where we do the math reasoning and all. We act and get 5 by 12 the times. So this total time takes it does the whole process of the calculation and all. We get the final answer of 2 hours and 24 minutes. In the reflect phase, what we does is the problem asks for the time takes to fill the tank. Both pipes are open together. So this time must be shorter than the given types. It uses this given reasoning so as to reflect on the answer. So 2 hours and 24 is less than the given times 4 hours and 6 hours. So the answer will be double checked using another mechanism and all. And this is finally given the final answer is 2 hours and 24 after the reflect phase. If we find any errors in this reflect phase, we'll again go to the plan phase, act phase, and move to the reflect phase again. So that's the topics of plan act reflect. Does anybody have any doubts? So that was my topic today. I dealt with setting up an environment of LangChain plus Gemini. I showed out how to get an API key and explained how to create a tool with the example of a BMI tool. And we learned two patterns, the React pattern and the plan act reflect pattern. So which was of the research agent and math logic agent. So that's it. That's my topic today. And I'll post a assignment for you in the group.